cannot create a whip using standard sew cord. This practice violates electrical codes for several reasons. Firstly, sew cord is not rated for use in concealed locations within walls or ceilings. The National Electrical Code, or NEC, specifically addresses the types of wiring methods approved for different applications, and sew cord is intended for flexible connections in exposed locations where it is easily accessible for inspection and maintenance. Secondly, standard electrical junction boxes, often referred to as J-boxes, are not designed or listed for direct use with sew cord. J-boxes are typically used with rigid or flexible metal conduits or non-metallic sheath cables such as type NMB, which provide mechanical protection and secure connections. The design of a J-box does not provide adequate strain relief or protection for sew cord, which can lead to damage to the cord's insulation and potential electrical hazards. The proper wiring methods for creating flexible connections, or whips, involve the use of flexible metal conduit, often called Greenfield, or liquid-tight flexible metal conduit. These conduits are specifically designed to protect conductors in flexible applications and are suitable for use with sew cord, provided that the appropriate fittings are used to ensure a secure and code-compliant connection. To understand why sew cord is not permitted in concealed locations or directly with J-boxes, it is important to consider the potential hazards. Firstly, sew cord is more susceptible to physical damage than conduit or cable. If the cord is run through a wall or ceiling, it could be easily punctured, crushed, or abraded, leading to shorts, ground faults, or even electrical fires. Secondly, the lack of proper strain relief at the J-box can cause the conductors inside the sew cord to become loose or disconnected over time. This can result in intermittent power supply, equipment malfunction, or even electrical arcing, which is a major fire hazard. Greenfield and liquid-tight conduits, on the other hand, provide a robust physical barrier that protects the conductors from damage. They also provide a secure connection to the J-box, ensuring that the conductors are properly supported and strain relieved. Furthermore, these conduits can be grounded, providing an additional layer of safety in the event of a fault. The NEC outlines specific requirements for the installation of electrical wiring and equipment to ensure safety and prevent electrical hazards. These requirements cover aspects such as conductor sizing, overcurrent protection, grounding, and wiring methods. Using sew cord in a manner that is not code compliant can void insurance coverage and create liability issues in the event of an electrical incident. It is also important to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local codes. These professionals have the knowledge and experience to install wiring and equipment safely and correctly. When creating a flexible connection or WIT, the following steps should be followed to ensure code compliance. Firstly, select the appropriate type of conduit, either Greenfield or liquid-tight flexible metal conduit, based on the environmental conditions and the degree of flexibility required. Secondly, choose the correct size of conduit and conductors for the application, taking into account the ampacity requirements of the equipment being powered. Thirdly, install the conduit using approved fittings and connectors, ensuring that all connections are tight and secure. Fourthly, pull the sew cord through the conduit, being careful not to damage the insulation. Fifthly, connect the conductors to the terminals in the J-box, ensuring that all connections are properly tightened and insulated. Sixthly, ground the conduit and J-box according to the NEC requirements. It is also important to inspect the installation regularly for any signs of damage or wear and tear. If any problems are detected, they should be addressed promptly by a qualified electrician. The NEC provides detailed information on the proper use of sew cord and other wiring methods. It is essential to consult the NEC and local codes before performing any electrical work. Additionally, it is advisable to seek guidance from a qualified electrician if you have any questions or concerns about electrical safety. Ignoring these guidelines can lead to serious consequences, including electrical fires, injuries, and property damage. Proper electrical wiring and installation practices are critical for ensuring the safety of people and property. Always prioritize safety and consult with qualified professionals when working with electricity. For example, consider a scenario where someone attempts to create a whip using saw cord and a standard J-box to power a piece of equipment in a workshop. The saw cord is run through a hole in the wall and connected directly to the terminals in the J-box without any strain relief. Over time, the vibrations from the equipment cause the saw cord to become loose at the J-box terminals. This creates a loose connection, which leads to electrical arcing. The arcing generates heat, which ignites the insulation on the saw cord and the surrounding materials in the wall. This results in a fire that quickly spreads throughout the workshop, causing extensive damage and potentially endangering lives. This scenario illustrates the importance of following code-compliant wiring practices. If the person had used Greenfield or liquid-tight conduit with appropriate fittings, the saw cord would have been protected from damage, and the connections would have been secure and strain relieved. This would have prevented the loose connection and the resulting electrical arcing and fire. Furthermore, the NEC provides specific guidelines for the ampacity of conductors, which is the maximum amount of current that a conductor can safely carry. It is essential to select conductors that are appropriately sized for the load they will be carrying to prevent overheating and potential fire hazards. The NEC also requires that all electrical circuits be protected by overcurrent devices such as circuit breakers or fuses. These devices are designed to trip or blow in the event of an overload or short circuit, preventing excessive current from flowing through the conductors and causing a fire. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, causing the overcurrent device to trip and energize the circuit. This protects people from electric shock and prevents damage to equipment. The NEC outlines specific requirements for grounding electrical systems and equipment. These requirements cover aspects such as the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metallic parts. It is also important to ensure that all electrical equipment is properly listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or OL. Listing and labeling indicate that the equipment has been tested and meets certain safety standards. Using unlisted or unlabeled equipment can increase the risk of electrical hazards. In addition to following the NEC and local codes, it is important to implement a comprehensive electrical safety program in the workplace. This program should include regular inspections of electrical equipment and wiring, training for employees on electrical safety procedures, and the use of personal protective equipment, or PPE, such as insulated gloves and safety glasses. It is also important to have a written electrical safety plan that outlines the procedures to be followed in the event of an electrical emergency, such as a fire or electric shock. This plan should be reviewed and updated regularly to ensure that it is effective and relevant. Furthermore, it is essential to promote a culture of electrical safety in the workplace. This means encouraging employees to report any electrical hazards they observe and providing them with the resources and support they need to work safely with electricity. By following these guidelines, it is possible to significantly reduce the risk of electrical accidents and injuries. Electrical safety is a shared responsibility, and everyone has a role to play in ensuring a safe working environment. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution and consult with qualified professionals when working with electricity. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. The NEC is a complex document, and it is essential to have a thorough understanding of its requirements to ensure compliance and safety. The NEC is updated every 3 years, so it is important to stay current with the latest edition. In addition to the NEC, there may be local codes and regulations that apply to electrical work. It is essential to check with the local authorities to determine the specific requirements for your area. Electrical safety is not just about following the rules, it is also about using common sense and exercising caution. Always be aware of the potential hazards and take steps to mitigate them. By following these guidelines, it is possible to create a safer and code-compliant electrical system that will provide reliable power for years to come. Ignoring these guidelines can lead to serious consequences, including electrical fires, injuries, and property damage. The cost of non-compliance can be significant, both in terms of financial losses and the potential for harm to people. Therefore, it is essential to prioritize electrical safety and ensure that all electrical work is performed by qualified professionals. Electrical safety is an ongoing process that requires vigilance and attention to detail. It is not a one-time event. It is a continuous effort to identify and mitigate electrical hazards and to promote a culture of safety in the workplace. By making electrical safety a priority, it is possible to create a safe and healthy environment for everyone. The NEC and other electrical codes are designed to protect people and property from electrical hazards. They are based on years of experience and research and represent the best practices for electrical safety. It is essential to follow these codes to ensure that electrical systems are installed and maintained safely and correctly. Failure to comply with these codes can have serious consequences. Therefore, it is imperative to prioritize electrical safety and to ensure that all electrical work is performed by qualified professionals who are familiar with the NEC and local codes. Electrical safety is a shared responsibility, and everyone has a role to play in ensuring a safe working environment. By working together, it is possible to create a culture of safety that will protect people and property from electrical hazards.